Okay, in this video, I'm going to show you another example of multiplying by 1 with a slightly more complex problem. Okay, you might want to watch the other videos to help you out a little bit. Now, remember what the idea behind multiplying by 1 is. Multiplying by 1, remember, doesn't really change any quantities here, but it does help change the way a problem looks. And specifically, we're trying to get rid of denominators, right? Because denominators can be a little difficult. So what we're going to do first is we're going to multiply everything so that there's just additions and subtractions in this problem. Now you'll notice that I can multiply by this half and distribute that, and look what happens when I do that. So I'm going to use little Roman rules over here to keep track of my organization, right? Please do the same. You get 5/3 plus, now let's go ahead and distribute. 1/2 times x is half of x, right? So x over 2. 1/2 of a negative 1 is just minus a 1/2. And then that's equal to 4. Okay, now, remember I said that the goal was to try to get everything into additions and subtractions, and now I've got that. The reason I want to do that is because I need to multiply each term. Remember what a term is. A term is any combination of numbers and variables separated by additions and subtraction. So like 5/3 is a term. There's an addition and there's a subtraction. X over 2 is a term. 1/2 is a term. 4 over 1 is a term. And what I want to do is I want to multiply each term by some kind of a 1 so that all my denominators are the same. And I'll explain why in just a second. So let's look at these. 3, 2, and 1 are my denominators. Remember, whole numbers have 1 as their denominator. So the question is, what is the common denominator for all of 4 of those terms? And the answer is just 2 times 3 times 1, or 6. So the common denominator is 6. Sometimes people call that an LCD, or the lowest common denominator, but we just don't really need to have the lowest one. We just want a common denominator. So here's the next part of the process. This is where the multiplying by 1 comes in. What's going to make this denominator here, this 3, a 6? Remember, I have to multiply it by 1. So what I'm going to do is multiply it by 2 over 2. Why do I do that? Well, notice that 2 times 3 gives me the 6 that I'm looking for, but multiplying by 2 over 2 doesn't change this 5/3. Let me just go down one more step and show you what it does look like. Remember how to multiply fractions. Numerators, that gives me 10. Denominators, that gives me 6. I've just transformed 5/3 into 10/6. It's the same quantity, but now it's got a different form. The form now has a denominator of 6. Okay, let's continue. Let's do the same thing with this x over 2. What do I need to multiply this denominator by in order to make the common denominator of 6? Now, remember, it's got to be some kind of a 1. I'm going to multiply by 3 over 3. X over 2. Let's go ahead and continue this. 3x over 6. 3x over 6 is the same as x over 2, but look what I've done now. Now I've got common denominators. Okay? I'm not quite done yet. I've still got these two terms rather, to do. Let's do that. Again, what do I have to multiply 1/2 by to get 6 in the denominator? And it's going to be the same thing as over here, right? It's 3 over 3. There's a 1/2. That's going to give me 3 over 6. And 1/2 is basically just 3 over 6 in a different form. And then finally, 4 over 1. How do I make the 1 a 6? I'm going to multiply by 6 over 6. And I'm going to get 24 over 6, which again is just the same thing as just 4. Now it's just transformed as 24 over 6. Look what I've done. I've multiplied by 1 for each term. A different kind of a 1. I had to do whatever was appropriate after I figured out what the lowest common denominator was. And now I just multiplied everything through by 1 and got the common denominator. Why? Well, once you've got the common denominator, here's the cool trick. you can cross them out. How can I do that? Think of counting numbers, you know. Let's go over here for just a second. Remember the counting numbers, just like 1, 2, 3, 4, etc., etc. What's the denominator in each of those whole numbers? You say, wait a minute, it doesn't have a denominator, but it does. The denominator is 1. We never write them in because now since they're all the same denominator, they're all proportionally the same. So we just really kind of cross them out. We never use them. It's the same trick or the same idea over here. Once you've got the 6 as a common denominator, everything in the numerator is now proportionally the same as what it was up here. All right? Look what I've got now. Let's just rewrite this as a clean problem. 10 plus 3x minus 3 is equal to 24. And look how much easier that problem is than the original problem up here. Now we can just isolate the x pretty rapidly, can't we? Let's just go ahead and do that. Let's combine like terms, so the whole digit numbers are going to give me 7 plus 3x is equal to 24. Let's go ahead and subtract 7 from both sides. You can do that, right? It's an equation. So as long as you do the exact same thing to both sides in terms of quantity shifting, you can do that. So subtract 7. That's going to give me 3x is equal to what? 17. That's step 7. And then finally step 8. 1, 2, 3. Let's divide both sides by 3. And I'm going to get x is equal to 17 thirds. And there is your answer. If you were to take 17 thirds, plug it back up into here, work the problem through, you get this side will be equal to 4 and this side is 4. You'll have the correct answer. Okay, I hope that was helpful.